Vlsi lab inverters layout. So before starting this, in the previous video we discussed about the schematic of the inverter. So in that, this was just kept empty, and uh, the final result what we can interface from that is Wn is equal to 2 times of Wp. We will get the optimum condition, that is delay will be very less. We can see here the TP is 121 picosecond, but here it is more, and here also it is little bit more. So after this schematic, now we need to create the layout. So for that one, if you are watching this video for the first time, please go to the previous video and watch the schematic, or else you can start directly creating the layout. So for that, this is the electric tool we are using, and here you just need to create one library, Vlsi any library name, and right click on it. Okay, so now we already have the inverter schematic. So now we are going to create the layout. So right click on this and create new cell, and click layout, and here inverter give as the same name and click OK. So here there will be the inverter layout section, that means inverter layer window. Control G for grid on and off, and here go to the components. So initially we need to form the NMOS and the Pmos. So for that, let's form the NMOS. Click on this NMOS and click here. Okay, so now for this we need to give the an act on each side. So and here also this, and this has to be the size, width of 10, width is 10 and length is 2. Click apply, and okay, so then close this, and for this also width is 10, and for this also width means width and length are basically only for this one, that is the gate length and the width. So for this act, that means these inactive contact regions, we just need to set the x-axis size with respect to this width. So I am making this x size as 10 and click apply and click OK. Then we need to connect from here to here, that is just left click on this, okay, this position, and come here and right click, so it will be connected. And similarly from here, just left click and come here and right click, so this will be connected. And click on this and drag this near this one until it will give the inactive spacing is 3. Okay, if you take more compact than the 3, then this will give the error. So error inactive spacing is 3, minimum is 3, so just keep it at 3. Okay, similarly keep this exactly, okay, align this like this. So this is the NMOS that we formed. Okay, so this is our NMOS. We just have it here, and now we need to create the Pmos. Okay, NMOS we need to have it here, and this one we just need to rotate this. So Control J, type Control J. So this is our NMOS now. Okay, so this is our drain, gate and the source, like that we can consider. Now we need to create the Pmos. So just go to the Pmos and click here, that is the Pmos, and go to the P act, that we need to click here, and again P act, that is the above. Okay, so then the Pmos length and the width, that also the width will is 10 and the length is 2. Click OK or click apply and click OK. So in the Explorer you can see in the schematic the length is 2 and width is 10. So the same thing we are doing here. So here again we need to set the x-axis to 10 and click apply, click OK, and here also the x-axis to 10 and click apply and click OK. So now we have properly aligned this. So you can even zoom these things to check whether it is properly aligned or not. Okay, this is aligned, and the above one we need to align properly like this and connect it just similar to the Pmos. Just connect like this and take this nearer to the gates, that is minimum spacing has to be 3, and here also just take like this near the gate. Okay, so now we have the Pmos, and okay, so okay, so how we can control all this zooming, all this shortcut means type control, and in your keypad 1 2 3 these buttons are there, right? So 4 means left, right, it will move, and 8 up, 2 down, 7 means zoom, and 9 means zoom out. Okay, so this also we just need to rotate this, so control J, and have this aligned to this one. Okay, so this has to be aligned like this, and after like every step you can just go to tools, DRC, check hierarchy. Okay, so that if any DRC error, that will be displayed here, no errors warning found. Like if it is not aligned or if it is not properly connected, the error will appear here. You need to correct those errors. So now in the inverter, so we can see here the for this gate and this gate, these two gates are connected, and for those two gates we are supplying the input. That means this is the gate of Pmos, this is the gate of Nmos. These two need to be connected. Okay, directly you can connect, and here we need to give the input. Okay, so for here we need to give the input. Here we need to give the input. Okay, and output. Okay, so here you see the output we need to, so this is the source of Pmos, and this is the drain of the Pmos, and here this is the source of the Nmos, this is the drain of the Nmos. That means both the drain are shorted. Okay, so we will consider this as the drain, these two as the drain. So this is the drain of the Nmos, this is the drain of the Pmos. So these two we need to short. Okay, so directly just click on this and just right click on this, that will be connected using the metal one, or else okay, so or else what you can do means, here you need to select the metal one and click, come here, left click and right click, these two will be connected. Okay, so this is our output. Okay, so this is our output, this is the drain, this is our output, and here we need to form the, okay, just tools and go to DRC, check hierarchy, there is no any errors. Now we need to form the VDD and ground. So for that one, so this is the Pmos, so you just need to add the N well for this one. So just we need to go above of this, and okay, so have it here, this region is there, right, that has to just touch the this region. So okay, or else just increase its width to 10, anything is fine, 5 or 10, just increase its width to 10. Okay, so similarly here there is a Nmos, so we need to have the P well. Okay, P well, we just need to place like this, and we can increase this from 5 to 10. Okay, so or else you can keep as a 5, no worries. And we need to connect the source of this PMOS to this VDD. So this one we need to connect here, and similarly this one we need to connect here. Okay, this we connected. Now we can check once the tools, go to check hierarchy, there is no any errors. So for example, I will just show what is that error. So if we have something like this, and if we check the DRC, and here this will give layout found 9 errors, and here you can see all those errors. Okay, so if any errors if you made, it will be spacing, all these errors will be there here. Okay, so now if you just click on this, it will display the error also. So that is just for the numbing purpose. So now let's clear these errors, delete all. Okay, now if we check the DRC, there will be no any errors. Then these things we did. Now we need to, here this is not the metal, so we are only allowed to give the input for this metal. So here we can directly just select this and Control E, that is create expert, and V out. So here select the output, so there is output, and click OK. So then you can simply drag this okay, not this one, you just need to plus control and just click on this, yeah, this one you can drag it outside. And here there is no metal, so directly we cannot give input from this gate diffusion. So what we need to do means go to the components, and here we can find the via. Okay, so that is what is this, so it will display here. Okay, so if we just go to the cursor, so here it in this place it will display metal 1 polysilicon 1 contact. Yes, we need this contact because we need to convert from this polysilicon to the metal. So just have it here, and okay, just have this here, and here we need to click on this metal, and we need to have this metal like this, and this one just delete it, just move like this, and from here we need to connect it this to here. No, it has to be okay from here to here, yeah. So now just go to the tools and DRC check hierarchy, so there is no any errors. So now this one we can connect it to the input, that means Control E, that is create expert, and here V in, and click here, and input, click OK. So I guess this is what is this, this is output, right? Yeah, this is output and this is input. Then you can just simply place this across here. Okay, so now we have V in and V out, and here for this one we need to tell this is VDD. In schematic there is no need of telling this as VDD and this as ground, it will take default, but in the layout we need to specify. So just select this and press Control E, that is create expert, and this is VDD, name it as VDD, and here go to the power. Okay, then click OK. So here there is a VDD, and this one also similarly create expert and G and D, and here go to the ground and click OK. So in the layout we need to specify these two. And another thing we need to add is the set spice model. This is for the Pmos. Just select this middle, that is the gate, this one, this Pmos. So just select this one and go to tools and go to spice, set spice model, and this will appear here. You can zoom this, you can okay, so just go here, even let's zoom only this part. So here is the set spice model, and this one press the control button and just click 2 to 3 times in this place. so it will select only that X mark, okay, so that it only, otherwise it will move, see, otherwise it will move complete the things. So you need to only move that set spice model, this part. So if you press the control, then you can get the control over that mark, okay. So okay, so here I have what I will do means, okay, yeah, like this we need to similarly do for this one. That is, just click on this and go to tools and set spice and set spice model, and here also just press it here, and here just name it as Pmos, okay, Pmos, and this as Nmos, okay. So you can just have it nearer to that. So Pmos and Nmos, yeah. Now this is VDD and V in, V out, everything is done. Now we need to add the, go to the components and okay, so here MISC and add the spice code. So here we need to have the spice code that is similar to the schematic. So just press Ctrl I and multi-line text, and so VDD 0 DC 5. So this is the for VDD, and another thing is V in 0, and so we are giving the pulse, so 0 pulse, and this pulse will going to take the initial value, that is 0, and the final value, that is 5 volt, and it will going to take so TD, that is the delay time TD, and TR rise delay, and TF, and pulse width, and time period. This value we we will have the same value from the schematic, so I just wrote TDTR. We will edit this, and we even need to have what kind of simulation it is, that is dot transient. So this is for the 200 n, okay, 200 nanosecond, and dot include this file is C5 models dot txt, okay. Just click apply and click OK. So now go to the Explorer schematic. What is the value we have? So here 0 5 1 n, that same value, that's why I just copied this, and remaining everything is same, okay. So here it is with the comment, you can this is just for the format, you can read it from here, the format of these V in voltage name and N plus. So this I explained in the schematic video, you can just watch that, the format of this spice code. So now we need to copy that to here, okay. So 05 TDTR, it is there, right? So here pulse 050 1n 1n 10n 20n, okay. So yes, this is the TD and TR, TF, and this is the pulse width, and this is the time period. So dot time 200n, then click apply, click OK. So here also we wrote the same thing, C5 models.txt, and here also that same thing. So same spice code we can copy from that, and now go to the tools and click check hierarchy once if any errors, okay. There is no any errors. Then go to tools and go to the spice and write spice deck. So now this will going to give the output. So go, click add trace V in and V out, So click OK. So this is the inverter output waveform. So we can have the add plot plane, and V in you keep here and V out. So this is for V, and that is double N is equal to double P. So okay, so here double N is equal to double P. But if you change this, the capacitance may going to change, the parasitic capacitance may going to change. So better change in this schematic, like in this layout we need to change, like make this as a 10 20 like that. That means 2 times of double N equal to 2 times of double P. That you can just change by click here, and width you need to change. So like that you need to change and you need to do. Okay, so I guess directly changing here will not going to work. So this is the NMOS double N. So double N equal to 2 times of WP means okay, we will just check it. No, I guess this will not going to work. Okay, so we are not going to see any more difference in the waveform. These values may going to change, I guess. So now similar way for the schematic what we measured, right? That is the three things, TD, TP, LH, that is delay, and TP low to high and high to low. Same things we need to measure even here for the layout also. So that is like we need to have the cursor. Okay, so for one TD, TL means from low to high, so that I think you can measure. So for this one, for one thing I'm just going to show you. So one thing we need to keep is, okay, so V in, we have one cursor here, just keep at the starting and click on the V out and the cursor. That we just need to have this cursor at the starting of the just okay, so at this point. Okay, so and this is that value we are going to get. Okay, so this is the value we are going to get for the TD, that is for the layout. So 108.719 picosecond. There is a small change here, so 108.719 picosecond. Like this we need to take all these values for this layout also. So here there is the capacitance, external capacitance is not necessary, because this will be going to have this parasitic capacitances. And another thing, so we need to do the layout versus schematic LVS. So for that go to just right click on the schematic and okay, so click edit in new window. Okay, so then go to tools, and here go to, okay, so here there is somewhere LVS, layout versus schematic. So okay, so check schematic and layout use of cell, no. So we just need to check this. Okay, so it will be there somewhere here. Okay, so okay, so we will just check this. I'll tell you guys so in just a second. Okay guys, it's just here, go to tools and NCC, and here cells from two windows. Okay, just remember, tools NCC, cells from the two windows, this layout window and this schematic window, that is LVS. So now that will going to display. So okay, so there is a, yeah, here this will going to display this. So comparing VLSI inverter schematic versus inverter layout, exports match, topologies match, sizes not checked in. Okay, so summary for all cells, it is matched. Okay, so it is giving it is matched. You can see if any layout versus schematic mismatch occurs, then that will going to display here. Okay, so NCC command completed. Then go to tools, and another one is the well error check. So ERC, okay, ERC check wells. So that also we are going to get the no well errors found. If any well error found, it will going to display. So that is the well error LVS. Okay, so there are basically the DRC and LVS. Okay, LVS we just did, layout versus schematic, and another one, third one is the well errors. Like we just need to go to the tools, and here we need to check ERC and check wells, layout versus schematic, NCC, and cells from two windows. Okay, so then this will going to give the, okay, so yeah, here we can see. Then another one is the RC extraction, that is the parasitic extraction from this layout. So for this one, we just go to the, okay, so just go to the file, and okay, so in the tools section, there is there any parasitic tab? So network placement routing, I guess go to in the, okay, so we will see in, so yeah, here is the parasitic something I did. Okay, so go to the file, preference, and here go to the parasitic. Okay, go to the, here in the tools there is a parasitic, tools and parasitic, and okay, so here we can, okay, layer we can select, and resistance and capacitance of the layer we can select. Now let's technology. Okay, so MOS, so here MOS, this technology, and we just select. Okay, so for all layers, okay, so we just select this, and go to, now to extract the parasitic capacitance, tools, and go to the network, and here extract current cell, click on this, and okay, so here okay, so extracting done. So okay, so here then what we need to do, tools, and okay, so This I think we just need to save. Okay, so go to tools and here network extract. Okay, go to tools, network extract current cell we did, and current hierarchy. Okay, so it is extracting, but we don't know how to see this parasitic capacitance. Okay, we will see that in the next video, like what is this parasitic capacitance, how to extract this. uh, just try to find it out, and if you get how to see the parasitic capacitance here, just comment it down. Even I need to learn this. Yeah, thank you.